Okay, we're going to look at the second one. Hopefully I can, again, kind of walk you through. All right, so part one is to find the probability that the person supports the racetrack. Let me know if you have a hard time with that part, because I can try to walk you through that part. Okay, so once you find the probability of this, the next part is to what are the odds in favor of the person supporting the racetrack. So if you remember, in the last problem, they talked about the odds is the number of, it would be like the number of number of E divided by the number of not E. Remember that? Okay, so we could go back and get those original numbers, but those are some really large numbers. Now I want you to look at something. Do you see that right here? Hopefully you can see where my mouse is. You see that you have the number of E, the number of E. Okay, so if you're looking at this probability, that would be the number of not E divided by the number of S. So all they're doing in this right here is that they're dividing it through and they're canceling out that number of S so that all you're left with is the numbers. I don't know if that makes sense or not, but that's where that formula is coming from. And they're doing that because using these numbers down here, 3/4, 3/4 and 1/4, that sort of thing, is a lot easier than using these large numbers. Technically, we could go back up here and use 3018 as the one number, and then add up these and let that be the second number. But that's working with some really large numbers. So I would much rather work with the small numbers down here. And it's just because these simplified are already simplified. So when you're dealing with probabilities, when you're dealing with a probability and you're looking for the complement of a probability, remember that all probabilities of a certain event will all add up to 1. Okay, so, like if you had eye color, think about eye color. What's the probability of it being brown? What's the probability of it being green? What's the probability of it being hazel? What's the probability of being blue? Okay, so all of those probabilities, let's just say that there's only those 4 colors. Okay, I'm just gonna be adamant. There's only 4 colors. So all of your probabilities will all add up to 1 or 100% because 100% of people have colored eyes. Well, okay, I guess you have the outlier every once in a while, but for the sake of this example, there's always going to be one of those 4 colors, and everybody has colored eyes. So that all adds up to 100%. And 100% in decimal form is 1. So all probabilities are going to add up to 1. So why can they just say 1 minus 3/4 over here? It's because they know that the probability of E and the probability of not E combine to give me 1. So if I know the probability of E, to find the probability of not E, you just subtract it from 1. Okay? Because if they're basically saying the probability of E is 3/4. Now, you don't know this yet, but the probability of not E is 1/4. So what do I get whenever I add 3/4 and 1/4 together? I get 1. Okay, so that's how they find the probability of not E. I don't know if that clarifies it at all for you, but I hope it does.